What are you working on? Let's go out somewhere.
I wish that I could. I'm busy working on a project right now. I have to make a video covering the pultrusion process.
Pultrusion? I've never heard of it. What is it about?
Well, pultrusion is a process that's used to make fiber-reinforced polymer pieces. This chair could be made using pultrusion, and in fact, a lot of what we have around us could be made using the pultrusion process.
Really? Can you explain more about it?
Sure. Would you like to take a look at my video? Maybe that would be better to explain the process.
Sure. I would like to see the video.
So, what exactly is pultrusion? Well, its name comes from a combination of the process features, pulling and extrusion. It's a process that forces a thermosetting plastic through a heated die to form a specific shape, similar to the extrusion process. But instead of the material being pushed through the die, the material is pulled through in a pultrusion process. The introduction of the reinforcing fibers is a key feature of pultrusion. It creates a composite polymer that is capable of handling high levels of mechanical stress while being much lighter than other materials with similar mechanical properties. So, what kind of fibers are used for this reinforcing? Let's take a look at a few. The most commonly used reinforcement material is glass fiber. This type of fiber has the benefit of being very inexpensive. It's also very lightweight, so it won't add much to the final weight of the product. It increases the tensile strength of the composite product so that it won't break under tension, and it increases the resistance to impact and chemical degradation so the final product will last for a long time. Some common polymer products that are reinforced with glass fibers include boat hulls, fiber optic cables, and large blades to be used on wind turbines. Carbon fiber is another widely used material for the polymer reinforcement. Carbon fiber is useful because it is incredibly lightweight, but while it is lighter than the glass fibers, it is significantly more expensive. It is also strong and flexible. When compared to a steel cable, a carbon fiber reinforced polymer cable had a higher tensile strength while having only 20% of the weight by mass of the steel. This makes carbon fiber an excellent choice when high strength to weight ratios are needed. Carbon fiber reinforced polymers are commonly found in the aerospace industry. They are used in some sports equipment such as golf clubs and snow skis, and they are also used in the construction of high-performance automobiles. Aramid fiber, more commonly known as Kevlar or Nomex, is also widely used in the pultrusion process. Bulletproof vests are constructed of Kevlar, and so a polymer reinforced with this material should be expected to have an extremely high impact resistance. Aramid polymers are also very lightweight, and they have a very high resistance to heat and corrosion. Aramid fibers can be found in things like hard hats, tennis racket strings, and in polymer materials that need to be incredibly resistant to heat or impact. So we know that pultrusion produces a final product that is lightweight and durable, but how do we go about introducing the reinforcing fibers to the polymer material? Let's take a look at this animation to get a better understanding of the pultrusion process. Here we get our first look at a typical pultrusion machinery setup. The process starts here at the creel, where spools of the reinforcing fibers are housed and fed to the later stages. In addition to the fibers, some setups will have woven fabrics that are used as veils or coverings that add an extra layer of protection for the underlying material. Here we see the pull winding process, where the fibers are braided into a shape that will be integrated into the final polymer product. After the fibers have been wound, they need to be impregnated with a thermosetting resin. This can be done in several different ways, but common methods include running fibers through a resin bath or injection of the resin into the braided fibers. There are several resin options to choose from. Polyester is most commonly used, but epoxy, vinyl ester, and polyurethane all have applications in the pultrusion process. After the fiber reinforcement is soaked with a resin, it enters the die where it is shaped, heated, and cured. When the polymer is set, it is pulled out of the die. Here we see a pair of reciprocating clamps pulling out the product, but simple rollers can also be used. The cured polymer can now be sent to a saw or some other cutting device where the final product is sliced to the desired length. The final product is now ready to be used for its intended purpose. Well, that's an overview of the pultrusion process. Hopefully you've learned a lot, and you now have a better understanding of what pultrusion is. The important thing to remember is that pultrusion is used to make a strong, lightweight product that has a number of advantages over other materials like metals and wood. Later, we'll talk in detail about the ways pultruded products are used and the types of benefits that pultruded materials have.
That's so cool.
Hey guys, how are you?
How are you?
I'm fine. What are you doing?
James here is explaining me about pultrusion process and it's very interesting.
Oh, that's cool. I know some stuff about pultrusion.
Really? Do you know anything about the history of pultrusion?
Yes, let me explain to you. After the formation of Rubber Reserve Company in 1940, many synthetic resins were invented and became available. This leads the scientists to propose different processes to use these polymers in producing different products. Pultrusion was one of the early inventions from 1940 to 1950. In 1944, J.S. Watson and his team submitted a patent for the first time on pultrusion. Here you can see the design of Watson's team from that patent, but the patent was not issued to them. Instead, the patent were issued to Goldsworthy in 1959. He filed his patent in 1953, 9 years after Watson. However, Goldsworthy did some pioneering work to successfully commercialize the pultrusion process, and that is why he is widely recognized as the pioneer and inventor of pultrusion process. Here you can see a cross-section of a commercial pultrusion machine from Goldsworthy's company in 1960s. The machine was pretty straightforward. The main parts of the machine were the material racks, where the fiber reinforced materials were kept, a resin tank, where the materials were impregnated with resin, a forming die, where materials were cured by some heating devices and formed to a specific dimensions, a pulling mechanism to pull the final product, and a cut saw to cut the product at a specific length. And that is how usually the final product was produced. There are many studies to determine different parameters for the optimization of pultrusion process. Some of the examples of such parameters are pulling speed, viscosity of resin, number and position of heating equipment and electrical power unit, die temperature, etc. These parameters also depend on the types of fiber reinforced materials, resins, and dyes used in the process. Nowadays, computer-aided PLC control system has been added to the pultrusion machine. This system gives the operator more control over these parameters to optimize the process for better products. Now let's see some of the important modifications of pultrusion machines. In the early time, the pultrusion machine could only produce structures with straight length and constant dimensions. To solve the problem, the molding system has been modified. Here you can see one process which can make tubular products by the constant winding of the filaments around the mandrel. Goldsworthy also proposed another process called pull forming in 1986 to create both straight and curved structures. Die curing chamber has also been modified over the years. Pre-curing and post-curing chamber has been added for better products. Also, more energy efficient heating processes has been introduced instead of costly and less energy efficient electric heaters. Some examples are UV assisted curing, microwave curing, sometimes resins can be injected from the top and the bottom parts. This is called injection pultrusion. The pultrusion process has also been used to produce micro-size structure. Here you can see 3 rods having diameters of 280 micrometer, 500 micrometer and 750 micrometer. These were fabricated using the micro-pultrusion technology. This creates an enormous opportunity to use the pultruded products in different fields like medical sectors and aerospace technology. Not only that, the size of the pultrusion machine has also been reduced significantly over the years. Here you are seeing world's smallest pultrusion machine named Pulcube. This machine has a length of 3.5 meter, which is 75% shorter than the traditional pultrusion machines. There are continuous research and innovations happening to pultrusion process. That is why the number of manufacturers increased from 20 in 1960s to 300 in 2006. The numbers are increasing continuously and it is getting popular all over the world. So we can say the future is very bright for pultrusion.
Oh, I get it now. But I have heard about other processing techniques like extrusion, injection molding, etc. Pultrusion, how it is different from other techniques like these?
I have a friend that's working on this project with me. I think he can explain it better. Let's give him a call. Woojun, how are you?
Good, how are you, James?
I'm doing good. I was hoping that you could help my friend better understand the differences between pultrusion and other polymer processing methods.
Oh, yeah, sure, I can help you with that. Let me show you my video.
Cool.
Here is one of the best composite fabrication processes called pultrusion. What makes the pultrusion process widely used in many industries? Let me start with comparing the pultrusion process with a similar method called extrusion process. Extrusion is one of continuous composite fabrication process methods, pressing raw materials such as aluminum into a die, and heated or cold worked aluminum become a desired product. Commonly, aluminum or thermoplastics are used for extrusion process. Unlike extrusion, in pultrusion process, a compound word of pull and extrusion, materials are pulled from a roving and saturated with resins in the resin bath, then cured in a heated die. Glass, carbon, or aramid fibers are commonly used as reinforcing materials from the roving. The resins used are polyester, vinyl ester, phenolic, and epoxy resins. The final composite from the pultrusion process is called fiber reinforced plastic or polymer, FRP. FRP has high strength to weight ratio, less heat and electricity conduction, corrosive resistance. It is versatile. Pultrusion process is considered to have fast processing speed, mostly 0.5 to 2 meters per minute. In 2017, there was a recent development by Kraus Maffei, German company. Their new pultrusion system called iPul system can reduce the processing time as 3 meters per minute. FRP also has uniform profile over cross-section, which results in consistent mechanical properties over the cross-section. However, pultrusion process has some limitations. The resin materials must be pulled through the die, and varying diameter or shape during the process is not feasible. With constant heat supply to the die, it may be less energy efficient than other fabrication process methods. Moreover, the materials used in processing are mostly not recyclable. Where are the pultrusion process and FRP used? Because FRP composites are versatile, they are globally used in various fields such as automotive, construction, electronic, and others. In 2016, FRP composites are used in automotive industry, approximately 40% of the share. Because of their exceptional lightweight to strength ratio, many auto companies have desired to use FRP composites for bumpers and other frames of an automobile. With the lightweight advantage, FRP composite also does an important role in construction industry. Roofing and siding, even some bridges are made of FRP composite. FRP composite is used in chemical and oil plants because of its high corrosive resistance and less heat and electricity conduction. Handrails and floor gratings made of FRP composites can stand under chemical environments such as water treatment area. Generally, FRP composites can be seen in our daily lives. Ladders, poles such as snow or golf poles, fencing and gates, even guy wires. FRP composites produced from Pultrusion process have been widely used in many different applications. Because of their outstanding properties, it is expected that the global market value of FRP composites will keep increasing. In 2020, the global market value was calculated as $121.39 billion. According to the research report, the estimated global market value reaches $198.71 billion with a compound annual growth rate of 8.6% by 2026.
Yeah, I understand the difference better now. Thank you, Kim.
Well, now that you have a better understanding of the process, maybe you can help me with the last portion of the project. Do you have any ideas for ways that Pultrusion can be used in the future, or any improvements that could be implemented?
Yeah, let me think of it. I think I work with biopolymers in my lab. Do you think using biopolymers with the antibacterial property to be used in this pultrusion process to coat composite materials to form devices or surfaces which have the antibacterial property in it? These surfaces need to be coated frequently in equal intervals of time as of now. If this pultrusion process is used for forming this resin-based coating on these devices, it will be a good boon for the biomedical industry, and I think that will be a good futuristic view.
Yeah, I can also think of another application. Like I work with soft materials, and some of the soft materials are pH sensitive or temperature sensitive, so they can change their shape like this. So we can use this technology to design some complicated shape and have some predefined shape changing behavior, and I think that would be helpful in the field like soft robotics, soft actuators, and yeah, I think this would be a good application for the technology.
What about using machine learning to optimize and automate the process?
Yeah, I think that is an excellent idea, because we can use image processing to analyze the product, and if there is any defect, so this image processing software will transfer data to machine learning algorithm, and this algorithm will take care of the processing parameters so that the defect will be removed. So this would be fully automated, more precise, and no extra manpower will be needed, and that's why I think it's a very good idea.
Great. I think I should have everything I need to finish my project now. Thanks, y'all.
No problem.
Great. Your project is done, so we can go out now. You should also join it with us.
Sure.